Hey guys, this is Mitch with FindPoint CGI, and today we're going to build a scalable sound detection system slash sound system inside of Godot. So we're going to go through the process of building out our surface resources. We are going to design out how we're going to play our audio from our player when they're walking and jumping and sneaking on a surface. And then we are going to go through and create a detection system that actually respects the walls between the enemy and the player. So that's what I have in store for you guys today. So let's go ahead and get started. All right, so the first thing we need to do is we need to plan out our actual system. Now, if you don't want to be here for that, that's totally fine. You can go ahead and just skip to the next time code and you could just jump right into the video. But we're going to run through kind of how I'm thinking we're going to do this. So first, we're going to come in and we are going to create what's called an audio resource. And what that's going to be is it's going to be an object that houses data, okay? And Godot resources are really cool because they basically give you the capability to have variables sitting out there for you to use in your code, if that makes sense. So what this audio resource is going to have is it's going to have a sneak sound. It's going to have a jump land sound. It's going to have a walk sound. And it's going to have a walk volume. And it's going to have a land volume. Okay. And this object is just basically going to house this data. And then what we're going to have is we're going to have another script here. And this script is going to be called a surface container. And this surface container is basically just going to house a audio resource. And that's basically all it's going to have. And that's going to house one of these guys. And this will be attached to every single object, if that makes sense. Every single surface that makes a sound will have this script. So the nice thing about this is we can extend this later. So if we have like an object that we pick up and throw and it hits the ground, we can basically extend this and have that additional logic right here and built into our stuff. What we'll do is when we walk, we're going to basically take a step, right? So we don't really have a player plan code, which we'll probably need to do in the next video. But what we'll do is we will check if we have inputs down. And if we have our stuff pressed down, then we will check if the player's crouched. And then we'll come over here and we'll play walk sound, and we'll play sneak sound. And then we will check if our player is in the air. And if they were, are they on the ground? Like that. And then if they are on the ground, play jump land sound. And that's basically how I think we're going to do it. Now, I know that this is kind of an abridged version of the code, but that's basically how I plan to have our player stuff work. Is we're going to check if we have our inputs down. If we are not crouched, then we're going to play walk sound. If we are crouched, then we'll play the sneak sound. If our player is in the air and then on the ground, then they will play the jump land sound. And that's kind of how we're going to handle doing our sounds. And of course, it's going to be a little bit different because we'll probably need to come in here and say set audio level, sound level to surface walk. Walk sound divided by 2 or 3. Technically, that's how it would go. And then same thing with play walk sound. I imagine we'll need to set some kind of audio level. So we'll drag this guy up and just copy that, paste, and then set it to walk sound like that. There we go. And then we also will need to do the same thing here like that. And We'll also need to set our on ground, our player in air value here. So once all of this logic has completed, we'll need to check is player currently in air, set in air last frame to true, set in air last frame to false. There we go. And then that will pretty much be the end of our little loop here. So we'll just do a little end guy here, like so. And that's kind of how we're going to do it. And actually, this should be a player in air last frame. And if they were not an air last frame, then we can basically just shut it off like that. And that's basically how we plan to do our actual system. Now, there is going to be a lot of changes to this once we go to a state machine in the next video, and we'll be basically planning it all out and diagramming it out and discussing why state machines are great. So that'll be kind of fun. Now, on the enemy side, we're going to be doing quite a few changes. So if we open up that, so I'll be right back. And we take a look at our enemy code here, or our enemy logic here. You can see that we have our hunting state. And what our hunting state is doing is it's looking around for the player. So what we need to do is when we do our patrol, we'll expand this quite a bit here. We are going to be looking for the player. So we'll need to create some logic for this. So we're going to get our direction, set our velocity, and then we're going to move towards point. And when we move towards point, we are going to check if players in range. And if they are, then we can actually go and check the player's light level. So get player light level. And then we will check the player's light level. Is light level higher than configured value? And I cannot spell configured. I guess that works, configured value. And if so, then hunt after the player. If not, then we will check our sound values. Is sound value higher than configured value? And if it is, then we will also set state to hunt like that. And then we can drag this out like so, and this one out as well. And that's kind of how we're going to approach our sound system, basically. And when we're hunting, we're basically going to grab this bit of code here and drag this down here. And when we do our look around for player, we'll basically do all of this again. Except for we will set our state to chase. Like that. And then this will be set to patrol. And we can just do that. I might have to come over. Actually, I can get rid of this. I don't know why I was messing around with that. There we go. And that's kind of what I'm thinking is basically we'll check our sound value and our light value. We'll set our states to hunt or chase, depending. I'm assuming if we're really close, it's going to set it to chase. And same thing with our hunting system is we will set it to chase if they are close enough. If we're in hunting state and we see the player, we're just going to chase after them. We know that they're there, so we're good to go. And that's kind of how we're going to approach it. So now that we have this kind of pseudo planned out, let's go ahead and build this thing. Okay, so the first thing we need to do is we need to get our sounds. Now, I already have sounds for my character, which is basically just a walk on concrete and on wood. And I have a landing sound from when I hit the ground from jumping. And that's going to be kind of the basis of our code. And then, of course, we're going to expand upon that in the future. But right now, that's going to be the basics. And what we'll do is first, we will get our sounds. Now, where I grabbed all of our sounds from was freesound.org. So if I come over to freesound.org, this is an awesome place where you guys can get all sorts of sounds for your project. So if I type like walking here, and I come over here and I hit like walking on grass, you can hear various sounds of various quality. So you can see this one has a lot of background noise and things like that. So it's going to take a lot of work to isolate that noise. And we also have stuff like footsteps in forest. And you can hear, once again, there's lots of background noise, and that's stuff that you want to avoid. So I've already pulled down and isolated a few sounds for myself. So I will leave a link in the description to a Google Drive, or of course to my GitHub, where you guys can download it. Now, if you do choose to download some sounds from Freesound to do your own processing, just be sure to pay attention to the licensing. If you take a look, you can see how there is a 0 here. This is mainly what you're looking for, or something like this, where it allows you to actually use it. So this means Creative Commons 0. It means you don't need to credit anybody. You can just download it and use it for your project, and it's totally okay. Whereas if you pick something like this one, this is licensed under the Creative Commons Attribution license, which means you will have to give attribution to the person that recorded the original sound. In this case, it's Leafs67. And if you see a symbol that looks like, if I can find one, let's see. Right here, if you see this symbol with the $sign and the little cancel button there, that means Creative Commons attributions, no commercial. So that means that you can definitely use it, but you cannot use it for commercial purposes. And you have to use attribution, so you have to actually give them credit for their work. So that's something to keep in mind. Now, I already have 2 sounds, so let me grab them real quick. And you can see I have 3 sounds here. So if I double click on concrete, if I double click on my wood, and I jump and land. And that's pretty much the sounds that we're going to be using. Now, of course, we're going to expand this and have lots of sounds, but I'm going to have a tutorial soon where I go through how to actually record your own foley and stuff like that, how to actually set up things and get things good, and how to actually record it and process it and stuff like that. I think that would be really useful for the community. And please let me know in the comments if it's actually useful to you guys, because I think it would be, but I want to make sure. But for this one, what we'll do is we'll just open up Godot, we'll tab into here, and then we'll just drag these guys in, and they will load like this. Now, one of the things that we missed in our initial project design was a sounds folder. So let's add one of those in. So we'll right click, add in a folder, and add in a sounds folder. And then we'll just select these 3 sounds and drag them into the sounds folder. So next we need to actually set up our different surface types. So if we come over to our test level, we right click on it, add in a child node, and let's add in a CSG mesh. And this is going to provide a nice test bench for us. So if we make it into a cube mesh like so, and we come in here, we can scale this guy down and make it nice and small like so. And then we can scale it just a little bit more, something about, I think that might be a little bit too big. So we'll make it about this big, and we'll drag this over here. And what we're going to do is we'll call this object a wood object, and then we'll control duplicate it and pull this over and say concrete. And once we have these 2 objects, basically once the user steps over this object, it needs to tell the player what it's going to be playing, okay? And we're going to do this through a lot of ways. Basically, the player is going to raycast down and get back the object, and then it's going to play the appropriate sound. But what we can do is we can actually have each one of these guys house that sound. if that makes sense. So how we're going to do that is each one of these objects is going to house a reference to a resource. Okay. And a resource is basically anything inside of Godot that exists is a resource. So you can actually make your own extendable resources right here inside of Godot. So I know you might be asking, well, how can I make my own resources? Well, that's the cool part is if you just right click on your scripts and you come in here and you add in a new script and you add in a surface resource, and I'm just calling it surface resource because that's what I would like it to be. And we can tell it to inherit from a resource type like that, and it will be a surface resource. So now we can hit create and it's going to open up Visual Studio. And you'll see that it's basically just an empty class. Okay. And what we can do is we can come in here and just tell it to house the data that we want. If you remember from our design, we actually came in here and did different types here. We have a volume of noise, the jump land sound, the walk sound, and the sneak sound. And honestly, now that I'm looking at this, we should probably duplicate this and hit volume of jump land. That way we actually have an additional sound here, because I imagine if you're jumping and you're landing, it's going to have a louder noise than if you're just walking on a surface. So if we go back here, let's go ahead and build this out. So let's build out our volume of noise. So public int noise level. And then let's say our jump land, right? So public int jump land noise level. And then we need to house our three sounds. So public audio stream, walk, stream, wave. And then we need to do the same thing for jump and land. So let's copy and paste this 2 times. So jump, land, and then our sneak. Just like that. And that'll basically pull back our resources. And if we leave this like it is, we are not going to see anything. And the reason why is because we need to export it. So if we come in here, we type export, and then we basically do the rest down the line. So we copy this, paste, 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 and paste. Control S. We come over here, we click on the build button, and then we come down here to our sounds folder. We right click, add in a new resource, and add in a resource, an actual resource here. And we will call it wood.tscn and hit save. Then if we double click on our wood, you'll see that, well, not much has changed, right? And the reason why is because you need a script to define what this resource is. Godot doesn't know what this is until we say, hey, this is what this is defined as. So if we drag our surface resource into here, you will see that we have a noise level, a jump and land noise level, a walk stream wave, a jump land stream wave, and a sneak stream wave. And then we can take this and go, okay, let me drag my footsteps on wood onto my walk stream, and then let me do my jump and land onto my jump and land. And since we don't have a sneak sound, let's just go ahead and grab our footsteps on wood and drag it on here as well, just because I don't actually have a sound for this. And then we'll set the noise value to something like 5 and the jump and land sound noise level to 10, and that should about do it. Now I can basically just grab this guy, I can duplicate it, so I can hit Control D, and I can rename it to concrete. And then I can double click on concrete and I can basically do the same thing. So I can grab this guy, I can say 6, I can say 12. Walk stream will be footsteps on concrete. Footsteps on concrete for our sneak, and for our jump land, we'll use jump land. And there we go. We're basically good to go for this part. Now we need each object to house that sound. So remember, our player is going to step on this object and then it needs to tell us what we are playing. So since it needs to tell us, we need to create a script for our CSG boxes to hold on to. So if we go to our wood, we right click on it and attach a script, and let's attach a surface.cs. And we select all of this and we delete it. And then we export out a surface resource for our actual object. Then that can house our sounds. Okay. And then we can come over here, we can click build, and then we can drag our resource into this. So in this case, this is wood. So we'll drag wood into it. And then this is concrete. So if we just drag our surface script, which has disappeared on me, there we go. We'll just drag this guy into here. Our surface onto our concrete. And then we now have all of our stuff set up. So that way, if we ever need to update our surface, we can just come in here and update our values right here, and it'll update project wide, which is awesome. And it saves us a bunch of time. So now that we have our actual system basically set up, let's see how we can have our player play that sound. So if we head into our player script and we head into our actual script, we need to set it up so that our player will be able to pull back the surface and actually play the sound. So first, we need to scroll down into about the front of our physics process here, and we need to do a raycast because we have to go and fetch what object we have underneath our player. So we're going to have to raycast every frame to kind of determine where we are in the world, right? What's under us? What kind of object is it? And much like down here, we did a raycast right, I believe, in our crouch code right here. So let's basically just grab this bit of code here. Let's just copy it, go up here and paste it. And let's close off that little if statement. And instead of having our space state down here, let's get rid of that guy. And then let's scroll back up here. And instead of saying result, let's just call it a surface result. So surface result. And what we'll do is we'll switch this to if surface result is greater than 0. That way we can basically say, hey, if when we raycast, if we come back with more than 0 items, then we know that we can go ahead and set our surface object. Okay. And currently our physics raycast parameters here just fire off to our current location up 2 points, 2 units. So instead, what we'll do is we'll hit enter on these guys. So that way it, looks a little bit better. And instead of doing what we were doing is instead we'll just hit -1 like so. And we'll basically just grab this guy and copy it and then paste it here and just say +1. And what that's going to do is that's going to fire a raycast in between our player's position. So it's going to fire it from right here to right here-ish. And I think that'll work. I mean, technically speaking, if we wanted to, we could do something like, 0.5 and it would still technically work, but it's up to you guys on how you guys want to approach it, of course. And once we have this, we know that we're firing our stuff back. We're getting back some kind of result, and we should be able to continue our logic, right? Now, one of the things that we need to do is we need to instantiate some kind of surface, right? We need to have some kind of surface that exists, if that makes sense. And we're going to need to default that surface to something. We can't just have it exist but not be an actual object. So what we can do is we can come in here and say surface is equal to, and here's where things are going to get kind of weird. We could instantiate a new surface every single frame, and that does work. But if we do that, it could be very slow. So instead, what we're going to do is we're going to come up here and we're going to create a kind of like a surface reset object for when the player can't detect anything, if that makes sense. So we'll say private surface init, and we'll come down here and we'll say surface init is equal to a new surface, and then we'll need to set our surface resource. So surface init dot surface resource is equal to a resource loader dot load, and we'll make that a specific type of a surface resource. And then we can pass in our resource location. So res://sounds/wood.tscn. And I believe it's tscn. Let me double check. It is TRES. That is my fault. TRES. There we go. And that should work. So now we can just come in here and say surface is equal to surface init. And then we can go ahead and set our surface. And the reason why we're doing this, and I know it seems kind of weird to do it this way, but here's why. So if our raycast does not come back with an object, or if our raycast comes back with an object that doesn't quite meet our specification, or the object comes back but it doesn't have a surface script on it, we need to default that noise to something, because if we don't, it's going to have downstream effects to our code, and we should always have defensive coding practices built into our code. And in the spirit of defensive coding, we should make sure that our surface result actually has a key called collider. So if we type if surface result dot contains key collider, then we can actually start running our code. And now we need to determine, we've determined that the surface has a collider, but now we need to determine if the surface actually is a surface object. So we can say if surface result collider is a surface, then we can go ahead and set our surface. So surface is equal to surface result collider, like so, as a surface. And we'll have to capitalize that S. And you'll see that we're going to have a small issue here. Cannot convert Godot variant to surface via reference, boxing, unboxing, or wrapping conversion. Now, I believe I've already talked about implicit versus explicit conversions, but basically the abridged version is an explicit version is me telling the compiler, hey, I know what I'm talking about. Do the conversion regardless of if it's going to crash my game. Whereas an implicit conversion doesn't really care as much. It will attempt to convert it, but it's not a guarantee convert. So what we'll do is we will guarantee convert it. So we'll say we know that this is a surface object because we've already checked it right here. We should be good to go. And that should work. Hopefully this will come back with the proper object. Sometimes it gets a little finicky, so here's hoping. And at this point, we should be okay with putting a breakpoint right here and running our project. Now, I don't think I've ever actually covered doing a breakpoint inside of Visual Studio. And I did an entire tutorial on how to do this, so I'm going to kind of do an abridged version. If we just click on this guy here, it is going to not work. It's going to say, hey, you can't do that. So what you have to do is you have to come up here, go into your debug properties, come into the launch profiles and say executable. Go out to the Godot executable, which in my case is the beta 3 executable. Click on open. In the command line arguments, type /path dot space /verbose. And then for the working directory, hit period, and then come down here and enable native debugging. And that'll pretty much allow you to do it. Then hit play and it should work. And if it doesn't, try switching your profile from one to the other and see how that goes. Now, if we head over here, we alt tab and we hit on this guy, well, we're not getting back what we want. If we hit on this guy, we do get a breakpoint. We are on a CSG box that is a normal of 0.1, position of 1.90054.4.17, CSG 3D box. I think, yep, I know what's wrong. Okay, so basically what's going on is if I look at Godot and I come over to my test level, I do not have collision on. So let's turn collision on for both of these guys. That was my fault. And then let's go ahead and go back to Godot here. Let's refresh our code. And then let's get over top of one of these guys. And it's not coming back. Well, that's unfortunate. So let's hit on this guy and let's see, do I get back the proper object? Now, we are returning the proper object. You can see here it says collider is wood, but it's not able to detect if it's a surface. I've ran into this before, and to be honest with you, I'm not sure how to fix it because in my testing of the previous version of this tutorial, this actually worked in my test bench, but for some reason now it's not. So I'm wondering if maybe there's a bug in the latest version of the beta that I'm running, which in this case is beta 3. So I wonder if maybe something got borked between beta 2 and beta 3. So let me see if I can find a solution and I will be right back. So it turns out, after a brief debugging session, when C# checks this object's type, it used to be back in the day in Godot Beta 2 that the object type was an actual object, but now it's a variant instead, which basically means that it's a very generic type. An object is like, this is an object. A variant means it legitimately could be anything. So what you have to do is you have to cast it as a Godot object, and then you're good to go. So now if I hit play here, you'll see that nothing seems to happen until you go underneath an object, right? And then once you go under the object, you see it snaps right here, and then we can hit forward, and then we can check our surface type. And you'll see that our surface type is a type CSG mesh. It has all of our CSG stuff. And if we head all the way down here to our surface resource, you'll see that our surface resource is null. So that's not a good thing. We'll have to figure that out. But we at least are getting back the surface that we expected. So that's awesome. So if we hit stop, and then if I fix my recording setup because I had to change everything for a second. So hold on one moment. There we go. And first, since we know that our stuff is coming back as null, let's take a look at our Godot scene and let's see what's going on. So if we select our wood object, you'll see that our surface resource is empty. So if I come down here, and I attach my concrete surface resource and my wood surface resource, that must have been due to the crash I had earlier. I had my driver crash for my AMD driver, so that probably messed a lot of this up. If I click on it, you can see here's all of our stuff. So all that's been still set up correctly. And if I click on my concrete, that's all set up correctly. So I think we're good. So now if we hit a breakpoint right here and we hit play, and we head over here, and we take a look at our surface type like so, and we scroll down to our surface resource right here, you will see that we have all of our sounds and all of our stuff right here. So perfect. We are exactly where we need to be. So now all we have to do is play our sounds and set up our audio levels, which is awesome. So I'm going to hit stop, and then we can go ahead and build the rest of this. So the first thing we have to do is we have to get a reference to our audio player. So if we head up to the top, let's create a class reference for this. So we'll just come in here and we'll say private audio stream player, foot audio player, and then we'll basically do the exact same thing, except for instead of foot audio player, we'll say jump audio player. And then we will set them up right here. So we'll just say foot audio player is equal to get node. And if you look at our little player here, it's called footsteps. So we'll grab that and we will say audio stream player like so. And then we'll just grab our footsteps. And then we could basically just duplicate this and say jump, because our other one is jump, and we'll change this over to jump as well. So first, what we can do is we can check if our audio player is playing, because if it's playing, we don't really want to fire it off and have it not work for us, if that makes sense. So we'll just say if not foot audio player dot playing, then we can actually play our audio. So we'll say foot audio player dot stream is equal to surface dot surface resource dot walk stream wave, and that'll set our sound as walk. And then we can come in here and just say footsteps foot audio player dot play, just like that, and that should play our sound. Now, when we let off of our button, we're going to want to stop it from playing, right? So in here, we can basically just do that. We can check if our foot audio player dot playing, and if it is, then we can say foot audio player dot stop, and that will cut it and say, okay, we're not going to play the sound anymore. And that's going to allow us to have better control over our movement sounds, because when the player lets off of the W key, you don't want to continue playing that secondary step, if that makes sense. Now, if we test this and we come over here and we hit play, we should hear some sound, hopefully, if everything's been done correctly. So if we run over here, there we go. And awesome. So now if we jump, you'll see it's still playing the sound even if we're jumping. And that's a problem because obviously if you're jumping, the sound should stop, right? Because you're in the air. So therefore, you're no longer walking. You're no longer actually playing that sound. So what we'll do is we'll do some counter coding here and say, and not is on floor, like that. And then we'll also check for it here as well. So we are checking here saying, hey, if foot audio player is not playing, and if we are on the ground right here, then we can play our sound. But if we're not on the ground, so else if we are not is on floor, then we will stop our play. Just like that. And what that's going to do is that's going to allow us to have a little bit more flexibility here because we're basically checking, are we currently in the air or not? No, we are not. So therefore, we are on the floor and we can play our sound. If we are in the air, then we can stop it. And if for some reason we get into a weird state, I'm just going to let this thing continue through and not worry about it and finish off the audio sound. Just in case there might be something funky going on. Odds are one of these two will be correct, but I just want to make sure just in case. Now, one of the other things that we have to do is we need to make sure that when we're crouched, we play the proper sound. So, how can we do that? Well, we can check if we're crouched, right? So we can say if is crouched, then our sound is this walk stream wave. Else, we know if if we are crouched, then we can play our sneak stream wave. And if we are not crouched, then we can play our walk stream wave. And that's basically how we can do it. Now, in our case, walk and sneak are the same sound, so it's not going to really sound any different for us right now. But once we get our sneak sound, it'll definitely make a huge difference. But I think that will work. So let's go and do our jump and land sound. So let's head up to the top up here to where our jump code is, and let's do some refactoring here. And we're going to have to make some changes to this little bit of code here because right now we're checking if you're on the floor and we're checking if you press the button. And that's totally fine for a jump, but to play a sound for when you land, it's a totally different world. So what we can do is we can check for if we're on the floor, and then if we have pressed that button, then we can jump. And that's totally fine. But we need to do some additional logic here to kind of check if we were in the air, okay? And that means that we're going to need a class variable up here to basically keep track of if we were in the air last frame. So we'll say private bool was in air last frame, and we can check for that right here. So we can just say if was in air last frame, then I know that my jump audio player dot stream can be set to my surface resources dot jump land wave. And then I could just play it. So my jump audio player dot play, and we are good to go. Now, we do need to set this value, and we can actually set it way down here at the bottom. And the reason why we're setting it way down here at the bottom is because we want to make sure that all of our stuff has ran, and we want to make sure that it's kind of the last thing that we do. And basically what we're going to do is just check to see if we are currently in the air or not, or I guess in this case if we are currently on the floor or not. Because if we're on the floor on this frame, in the next frame we can do that check again, and then we can kind of determine if something has changed. So we can just say was in air last frame is equal to not is on floor, and that will set this up for success. So if we come up here, what we're doing is we're saying, am I on the floor? Yes or no? If I am currently on the floor, was I in air my last frame? And if I was in air my last frame, then I will play this sound. Now, once we get down here, we are actually setting our was in air last frame to whatever our floor is but the opposite. So if we are on floor currently, then we are not in air and we're good to go. And then this logic up here will run. If we are in the air, this logic isn't going to run. And then this guy is going to get set saying, yes, we were in air last frame. And then once we hit the ground, it will come up here, we'll be on the ground, and then this guy will be true, and then it will play our sound, if that makes sense. So now we can just come back to Godot and test this, and it should work, hopefully. So if I jump, you can see it works. Cool. It looks like it works pretty well. So I think we're good to go. So now all we need to do is we need to set up our audio detection system for our enemy. And for us to do audio detection, we need to set up our values. And you remember back with our surfaces, our surface resources here, we have a noise level and a jump noise level. So all we have to do is come into our player, scroll up to the top, and much like our light value right here, we'll just set up a public double. Might as well keep them the same and just say noise value. So then we can keep with a nice little naming convention here for these little values. And then we can come down here, set our noise value equal to 0, much like we did with our light value. We set it to 0 every frame. So that way, when we get our new value, we can override it with that current value. And then we can come down to our jump and we can just say noise value is equal to our surface dot resource dot jump land noise value. And then we can come down here and we could do the same thing with our movement code. So we can come down here to where we're doing our crouched, and just above all of this, we can basically set our value. So we can just say if is crouched, then our noise value is equal to, and actually now that I'm thinking about it, I'm looking at this, we should probably do this instead. We should wrap, I think we should take this guy, come in here, and let's come up here and say if is on floor, like this. We'll wrap all of this guy down here to here. And then we'll get rid of this guy here because we know that we're on the floor right here. We'll check if we're crouched. And if we are, then noise value will equal surface dot our surface resource dot noise level. And then I'm going to make this divided by 3 because I want to say when you are crouched and sneaking, you are 3 times quieter than if you are walking. And then we'll just say else your noise value is equal to the surface resource noise value. And then if it's not playing, it'll play the audio. Else, if we are not on floor, it'll stop the audio. And I think that will work. So now that we have our noise value populated, now we just have to have it so that our enemy can detect it. So let's head over to our enemy and let's come down to where we have our check for player. And you will see that we have our player in earshot far and earshot close. Now, I've recorded this section probably 3 or 4 times now, but due to crashes and things like that, it hasn't really worked out. So hopefully this time it works. But I did just have a gigantic brain blast and thought of a different way to do this than what I originally was going to do. So I'm going to walk you guys through originally how I was going to do it, and then I will actually show you how we're going to do it for this. And I'm going to have to refactor the entire GD side of this tutorial because this system's a lot better. But basically, what originally I was going to do is I was going to check our noise value here against a fall off. So I was going to take our noise value, divide it by the distance, and then go from there, right? And then that would have been great, but that's only if the player can see us. So if we're hidden behind an object or something like that, then we can make as much noise as we want and the player doesn't care, or the enemy doesn't care. But instead, what I think we should do is we should take this bit of code here. We're going to copy this guy. Well, cut it, I guess. And we'll come down here and we're just going to paste it. And we're going to need to get a reference to our player. You can see how we have that P right there. So what we can do is we can come into our player, we can scroll up to the top, and we can do what's called basically a static reference to our player. So I'm just going to say public static player, and then I'm going to come down here and I'm just going to say player is equal to this. And that'll create a static reference within the project for my player. And then we can come back to our enemy and then we can just grab that instance. So we can just type player dot is crouched, and then we have reference to all of our stuff. And that makes things a lot easier for us when we're doing things in our enemy code. And then that opens up a world of possibilities for us. So what we can do is we can basically check if the player is behind something. Okay. So we can say bool player behind wall is equal to false, like that. And then we can come up here and say, okay, if we can see our player, right, we can raycast to our player, then player behind wall is equal to true. If we can raycast to our player, we can actually see them, then we know player behind wall is equal to false. And that basically allows us to determine if our player's behind a wall or not, okay? And if they are behind a wall, then we can do kind of like an additional fall off value to say, well, they're behind a wall, so it's going to be a lot harder to hear them, okay? So we can come down here and we can say, hey, if our player is in earshot close and our player dot noise value is greater than a specific value, so something like 0.4f, which we'll need to abstract this out into a class variable soon, but for right now we'll just do 0.4f. If it's greater than this, then run our hey player, we are chasing our player's in earshot, right? But that doesn't take into account the distance of our player, and it doesn't take into account if they're behind a wall. So what we can do is we can muffle the sound of our player based off of if they're behind a wall. So we could just come in here and say parentheses player behind wall question mark. So if player is behind a wall, noise value divided by 2. So we'll cut the noise value in half, or we'll just set it as our player dot noise value and see if it's greater than 0.4f. But since we want it to proportionally fall off as well, we can divide that value by our global position dot distance 2, not distance squared 2, our player dot global position. And I'm going to reformat this a bit so that it is easier to see. So player behind wall, question mark, noise value, and then divided by global position. Trying to think of an easier way to house this so it makes sense. I guess we can do that. That's not ideal, but it'll work. And that basically will handle it. So I know there's a lot going on here and I'm sounding extremely excited. So I'm not helping very much, but how this works is if our player is in earshot and if this value is true, okay? So if all of this stuff ends up being greater than 0.4, then our enemy can hear us, okay? And what we're doing here is we're doing what's called a ternary operator, okay? And a ternary operator says, if this is true, do this, else do this, okay? So if our player is behind a wall, then we are going to cut our noise in half. We're going to say, hey, they are behind a wall, so therefore it's going to be muffled. It's going to be harder to hear. And of course, we can play with this value and make it whatever we want, but this should make our system a lot more dynamic. And then we can basically just copy this guy right here and then just paste this and then come here and change this value to something like 0.6, saying you're farther away. So therefore your noise needs to be at a higher threshold for me to be able to hear you. Now, we could, of course, because we have proportional fall off, we could just leave this as, hey, if players in earshot at all, then just do a proportional fall off. And that might be a decent option. But right now, we'll do the 2, and then we'll leave it like that for now. And we don't necessarily want this 0.6 and 0.4 to be a static value. So let's scroll up to the top, and let's create some values up here. So we'll say private float close sound detect, and we'll make that equal to 0.4, which I believe is what we had. And then I'm just going to copy and paste this a few times because while we're at it, we might as well do our light detect. So we'll say far sound detect. We'll put this at 0.6. We'll say close light detect and far light detect. So far light detect. And then we'll just grab this guy and say close crouched light detect and far crouched light detect, and then we'll set these values to what we know, what we already have them set to, which in this case I believe close light detect was 0.3, I believe far light detect was 0.5, I believe close crouch detect was 0.3, and I believe this one was 0.5. I believe that that's about right. It might be 0.6 actually. And then we need to export these out. So let's just grab an export like this. Let's copy that and paste it in like so. So we'll hit click, paste, paste, and paste. And there we go. And then we could just come down here and set these values. So we'll say, hey, if players in sight close and light value is equal to close light detect. And then we can also have a close light detect crouched, and then far light detect and far light detect, crouched light detect. And then we can scroll down here and do the same thing here and type close sound detect and far sound detect. And there we go. And that should pretty much do it for us. So now we can basically test this. And if we've done it correctly, hopefully it will work. So we'll hit play. And you'll see he's heard me already. And you'll see he's hunting after me. You'll see he can't hear me. If I jump, he can now hear us. Awesome. That works. So he's now hunting us and he can see us now. So now he's chasing after us. Which I feel like there's a little bit of stuff here I'm not a huge fan of. I wonder if it's my sight mechanic. Maybe not. But as you guys can see, it seems to work pretty decently well. You can see that he hunts us, I jump, and I make some noise. He immediately comes to check it out. Awesome. Now you will notice that there is a bug. If our enemy is in wait state, he cannot hear us. And that's something that I've noticed is a slight problem. And it's something that we're going to have to take a look at. So if our enemy is in a wait state, no matter how much noise or how much stuff we do, it doesn't really change the fact that the enemy can't hear us. And the reason why is because we're doing a check for player here in our move towards point. But since we are in our wait state, we don't actually have a move towards point. So let's add that, and that will solve that problem. And at this point, we have a pretty solid little enemy detection system. Now, at this point, if you guys are happy with what you have, you're good to go. You guys can take off. But something that we should do is we should comment all of our code. So I'm going to run through and comment all of this code. And it's basically just going to be a fast forward, and then we'll get out of here. So I'm going to be right back. All right. So in the next tutorial, we are going to go through and refactor our player controller. I think it would be good if we move to a state machine. This system is getting pretty large for our player, so we're going to go through and refactor that. Then after that, we're going to talk a lot about level design. And we're actually going to gray box out our level and start actually building a game. So that'll be really exciting. So look forward to that in the future. But that is all I have for you guys today. So thank you so much again for watching. I will see you all next time. Thanks.